So, hello everybody, good evening.
Does it still work? Yeah.
Yeah, it works.
Hi.
Okay, hello. So good evening. I guess the first thing we should do is to introduce ourselves. Lazo, is that what we should do?
I think that's a nice thing.
You want to start, Anke?
Yeah. Oh, you can start.
Oh, okay.
Yeah, I think they prepared it to be your thing. This one? Ha!
Aha.
You see?
No, I didn't know that. Okay.
Pramení ako malý potok v Nemecku. Pri tom, ako postupne preteká Európou, sa do neho vlievajú ďalšie riečky. A on naberá na sile.
Dunaj.
Voda v ňom tečie tak rýchlo, že zo sebou berie menšie aj väčšie kamene, ktoré sa prevaľujú po dne. Pri Bratislavskom hrade prekonáva Dunaj žulový kopec, kvôli ktorému spomaľuje svoj tok. Voda už nevládze premiestňovať množstvo materiálu, ktorý sa tu začína usádzať. Za tisíce rokov sem rieka priniesla toľko štrku, že sa postupne usadil na asi 100 kilometrov dlhom úseku, ktorý má miestami hĺbku až 400 metrov. Voláme ho Žitný ostrov. Medzi obrovským množstvom okruhliakov je stále dosť miesta pre vodu, ktorá všetko miesto vyplní. Je jej tu toľko, že by naplnila 4 plavecké bazény pre každého Slováka. Vďaka tomu, že voda postupne preteká cez usadeniny, sa sama čistí a my ju môžeme piť bez veľkých úprav. Máme teda veľké šťastie, že tento bazén podzemnej vody vznikol práve na našom území. Naša jediná úloha je nezašpiniť si ho. Na Žitnom ostrove je voda veľmi plitko pod zemou, často už 1 meter. Preto stačí neopatrný zásah a ľahko môže dôjsť k znečisteniu podzemnej vody. Poľnohospodárske postreky sú však schopné prenikať do veľkých hĺbok. Ak sa dostanú až k zásobe vody, znečistia ju a my ju už nebudeme môcť piť. Ďalším ohrozením sú staré skládky a priemyselné závody, z ktorých unikajú jedovaté chemikálie. Ale vodu môžu znečistiť aj samotní ľudia, ktorí na Žitnom ostrove žijú a často nemajú pripojenie na kanalizáciu. Preto dnes hrozí, že si znehodnotíme drahocennú zásobáreň, ktorou príroda obdarovala práve Slovensko. Ale nemusí to tak byť. Dôsledným sledovaním používaných chemikálií a odstraňovaním záťaží nám naša voda môže ostať čistá aj pre naše deti. Prispejte aj vy na nezávislé vzorkovanie vody vo svojom okolí na www.zanašuvodu.sk.
Okay, so thanks very much for playing that. I didn't know actually that was going to be the start of this dialogues, so nice surprise. Yes, I'm part of this NGO, or občianske združenie za našu vodu, for our water. And it's basically what we are is a group of people who are chemical engineers like myself, or chemists, or hydrogeologists, or IT specialists, or artists. And all of us are basically enthusiastic people who want to make sure we protect the sources of drinking water for future generations. That's what we want. And I think this video said it all. It's a video that we made ourselves as part of a campaign where we want to bring people to realize what we have. If you ask, most of the Slovaks don't even understand or don't even know that we have this Žitný ostrov, that huge water reservoir. And I heard some people being surprised that, wow, we have 4 Olympic pools for every person in the country. So it's a huge, huge reservoir, and not many people actually know about it, and not many people realize that we are actually not protecting it really well, and we can lose it. So with the climate change really approaching us, the water will be a very important resource. I think it will be at some point definitely more important than oil. And I don't want to say Slovakia will be the next Saudi Arabia. I don't want that, but it will be really very important to preserve the resource for maybe not just this country, but for many other people in Europe who can use it for the daily use. So that's what we do in the NGO. We will speak about it later. There is some pictures about water reservoirs, important water reservoirs in Slovakia. And I'm just very happy to be part of that. It's a small group, but very efficient. And yeah, more later. Maybe Anke, you want to say something about what you do?
Yeah, that's Well, thank you, and I really share your concern about the water, and I really love it that you put in this, that you created this NGO. Let's see. I'm Anke. I'm from Amsterdam. I'm a landscape designer and nature connector. I work with nature and try to, wherever I can, to try to connect people to nature. And this is an overview of my workplace. It's called the Keuvel, and it's in Amsterdam. And what you see here is actually a bunch of ships. There used to be we have these houseboats in the canals of Amsterdam. These are old houseboats, all put on land. And we use them as creative spaces. The Keuvel is what we call in Amsterdam an incubator place, a place where creative people can get their workspace for less money, so that it's affordable for them. And in this case, it's a sustainable incubator, so we work on either ecological sustainability, but also social sustainability. So we're with 45 people. We form this community, and the Keuvel sits totally on polluted land. It's a brownfield, so it's one of the thousands of brownfields in the world. And this used to be an old shipyard. You can still see the railways that go to the water where they hoisted up the boats. And it was basically for 1 century a shipyard. It closed down in 2001 and left the site polluted. When we got it as the incubators, as the community, we decided that we get it 10 years from the municipality for free of rent, and then we have to give it back. We're 8 years further now, so we have only 2 years left. And we want to give it back cleaner than we got it. So that was the main goal. And one of the ways we did that is try to clean up the land that you see in between the boats. We call that the purifying park. And we try to work together with nature through phytoremediation to lessen the pollution of the area. And I have a small video of it that we use also in a sort of tour to explain a little bit more about it. And then you can also see a little bit of the Keuvel a little bit more.
Hi, I'm Anke Wijnja from the Keuvel. And one of the things I do here is taking care of the purifying park. The Keuvel is a brownfield, and like many brownfields we have a lot of contamination in the soil due to the usage, the industrial usage before. And classically the contamination like this is treated by just excavating the top layer of the soil, place the soil somewhere else and put in new soil that is cleaner. In that way you don't deal with the problem, you just put it somewhere else. We try to do it differently. And we try to do that with help from our green friends from nature by using a technique that's called phytoremediation. And phyto means plants, remediation means restoring balance. So it's restoring the balance of the soil through working with plants. Now, how do we do that? There are different techniques in phytoremediation. They're all linked to different types of pollution. And it's, in our case, that's a lot of PAH, which is polyaromatic hydrocarbons. Basically that means fuel spills, tar, like making tar for the ships to close them, to seal them. And the plants do a miraculous thing with that. They take it in, either really in the stem and in the leaves, or the microbes on the roots take them in, and then they break them down. So they break these long molecules into small pieces that are mostly non-toxic anymore. And some of them are used as building blocks for the plant itself, and others are evaporated. So just by planting these plants or trees like the poplar and the willow that you see here, you can clean an area like this from PAH or PCBs. And I think that's amazing. And it's one of the things why we do it here, because we want to inspire people and tell them that this is possible. It's possible to do it in a different way. Then there's another type of contamination, and that's more inorganic. And we have that at the Keuvel, I want to show you. And in our case, that means that we have a heavy metal pollution. Things like cadmium, mercury, lead, things that you don't want to be in touch with too much as a human. It's here because there was a workshop here. And so every part of the landscape has its own pollution due to what used to be here. The way you can deal with a pollution like this with the plants is through phyto extraction. And that means that the plant takes always in stuff like nutrients to grow. And in that case, some of them also take in the heavy metals in that process. So they take them in the stems, in the leaves, in the flowers sometimes even. And when you harvest the plant, before it all goes back to the ground, the pollution is still in the plant. So we take them out and we put them on a degradation pile where it can degrade safely. And in that way we know exactly where the pollution is, namely in the degradation pile that we can test and we can see how we treat it afterwards. So that's a benefit. We cannot just get rid of it. Heavy metals are basic elements that you cannot cut, you cannot break them down into other pieces. But in this way we get it out of the soil and out of the biological system. Now there are several plants that we use for that. Some of them we sow. Like this one, in Dutch we call it the tuinisbloem. It has beautiful yellow flowers. But also a type that's called, and it's really tiny, it's a brassica type. And it's really tiny now, but the brassica types, it's really funny. You most of the time you will eat them because they're like all the sort of cabbages are brassica types. And also things like pak soy, tatsoi, they're all from the same family. And they have amazing capabilities of to take in those heavy metals. And they're so-called hyperaccumulators, so they really take in lots of them. And every brassica type takes in different types of them. So we use a mix in the soil to deal with all the contamination with it. What is difficult is the results that you get with phyto extraction. It's a beautiful process, but it takes a while. And some heavy metals are more difficult than others. So for us, we don't expect to have the soil cleaned after the 10 years that we are here. What we more try to show to people is to let them see that it's possible to deal with contamination in this way, and to inspire and to figure out how you do this. So what I like about this whole process, how we do it on the Keuvel, is that it's low budget and with volunteers. That means that if we can do it, almost everyone can do it. And I hope that in that way it inspires people to look at alternatives for the classic way of treating polluted soil. And if more and more people do it differently, be it as a volunteer, be it as a small project somewhere else. They're here in the north, there are already gardeners that learn from us and do it in their own garden. In that way we can maybe fuel a movement in this, do it differently.
Very nice.
Thank you. So now you get an overview of what I do at the Keuvel.
So, Anke, you said there is several different ways of phytoremediation. Maybe now is a good time to speak, maybe not in too much technocratic way,
but just give a short overview.
Give a short overview of what phytoremediation can do. Can you tell us more?
Yeah, it's a sort of umbrella name for a lot of techniques. So you can see it as a sort of that you have different tools to do it, and the different tools all link to the processes that a plant has. A plant is a living thing. It takes in, it breathes out, it takes in nutrients, and it gives away sugar, for instance. So it exchanges continuously. And doing that, it has different possibilities to treat the contamination. And
so the plants actually take the contamination in their body, right?
Yeah, sometimes. Yeah. So when you have phytoextraction, what we use at the Keuvel as well, they really take in, for instance, heavy metals like copper or zinc or something like that, and they take it in, and at the time that the plant is on its prime, so it's as big as it can be. You harvest it, and then the pollution is in the plant, and you have to put it then on a separate place. Yeah, and you can treat it differently after it. But then you also have like something that they call phytovolatilization, which I really like. It's that the plant takes it in, but it's then a contaminant that it can easily sort of breathe out without polluting the air very much. But also to in that way just letting out the contamination from the soil through the plant.
I think it chemically changes also by the time it
does.
Yeah, I'm sure.
Wasn't sure, so I didn't mention it now.
We have some chemists here, right?
Yeah, I know. So that's also maybe nice to know that I'm not a chemical engineer. I'm an industrial engineer, so I have some technical backgrounds, and I'm a landscape designer, so I know something about plants. But I was just loving to do a thing like this, and then you dive in and you start working with it, and you meet all kind of people who tell you more about it. When you're curious and you want to do it, you can find the people that are willing to tell you. So you don't have to be a chemical engineer to start.
You don't have to be expert in everything, right?
Yeah, exactly. So just to encourage you all. Then you have the thing, and that's also Phyto Degradation. That's what the plant or the whole atmosphere, as I call it. You have these roots, and roots at the roots the plants exchange all kinds of things like sugar and nutrients with the whole rhizosphere that's around it. So it's a whole, I like to look at it as a sort of microcosmos around the plant. And in that exchange, sometimes the contaminants are degraded, so they really changed into some things that are less harmful or harmless, and then either evaporated or they just used by the plant, etc. And you have a thing called phytostabilization, which is actually binding the contaminant to the region of the plant, and in that way it won't wash into the groundwater, which is interesting for you.
Yeah, and we were discussing that because, of course, in Slovakia we have many brownfields.
Yeah.
Right. And actually, I checked there is a so-called like a list of all the contaminated sites in Slovakia on Enviroportal, and there is, guess how many?
Yeah, I think it will be hundreds.
1,800.
1,800.
1,800 of contaminated sites.
It's good that they have a list of it.
Yeah, they have a list.
Yeah.
And 800 of them has already been sort of either started or semi-started or almost finished remediating. So that's a good number. So still 1,000 remains. And some of them are quite heavy. And I think the heaviest ones, where you have actually quite heavy contamination, could be even toxic to some plants, don't you think? Or how do you think about it? Could it be?
Yeah,
that?
I know. You have when you have this contamination, you have to, and you want to do something with phytoremediation, you have to look at what kind of contamination you have.
Right.
for instance, also, we're talking about plants, so you have to also locate where the contamination is in the soil. You can imagine that if you have a plant, it grows on the topsoil. So
you
the
can
first
have contamination a few meters below, right?
Yeah,
It will not
so-
be touched.
So if you have a contamination in the first meter, it's easier to phytoremediate than when it's deeper than that. And trees can go till like 3 meters or something.
Right.
And below that, you really have to do something else. Like for instance, with groundwater, you can pump it up, irrigate it or something
Right.
through the plants, but you really have to look at that. So that's one thing. And the other thing that also has to do that you work with plants, they have to be able to grow.
Right.
So if it's too contaminated and you have different types of this contamination, and some contamination, if they're really high, it's too difficult for a plant to live on.
So maybe the first important step is really to assess the contamination. To
Yeah,
how
it
deep,
is.
how much, how wide. Yep.
Yeah.
And then you can actually link maybe some of the not so heavy ones, or after you do the heavy remediation, to leave the plants to finish the job.
Yeah, so you can see what kind of, that's really, we had a workshop today, and that's what I stated out as well. Like, you first have to assess what kind of contamination am I dealing with.
Yes.
And then a thing like this is a scheme that I really like, is in the colors you see the different types of contamination. I won't go technical into it, but just gives it's a nice graphic to watch as well. So, but it gives an insight in how successful you can fight to remediate something. So if it's more to the upper left, it's easier to remediate through phytoremediation. And right down, like lead is one of the most hardest to remediate a site. And you see the different techniques that you can use. So yeah, that's first the most important thing, and then the amount of remediation. So sometimes it might be what they often do is when you really have this local place of contamination. So it's really the heart of it or something.
Epicenter.
The epicenter, I like that word. The epicenter of the contamination. It might really be good to treat that in a different way.
Technical way.
And then you can also see there are different types of that as well, in situ or somewhere else. But then there are usually larger areas around it that are even sometimes harder to excavate or to treat.
Or it's too large of an area.
It's too large of an area, and then you can look at the phytoremediation a better way.
We spoke about Zemplín, and not many people here know. I'm not sure if we come.
Oh yeah,
with that hand, I will just go to that. Yep. This is actually one of the most serious contamination areas in Slovakia. It's in Zemplín, close to Chemko-Strážske, town of Strážske. I'm not sure if people here in this hall know it, but it's a 30-year-old huge contaminated site. It actually contains, it's actually called the Triangle of Death. It has that name. Maybe I have a slide that shows the whole triangle. I hope I will not have to go all the way back.
Yeah, it's
probably.
I think it's
somewhere.
at the end.
There it is. Yep. It's basically a place between the whole area between Vranov nad Topľou, Humenne, and Michalovce. So you can see it's a huge area, and there is this part of Zemplínska Šírava that actually most of it should be in it. And this whole contamination started when there was a chemical plant in Chemko-Strážske. I will not go into the details, producing these persistent organic chemicals, PCBs, and I saw them on your chart, Anke, which are very, very difficult by plants to actually extract from the soil and remediate. But since we are talking about such a large area, of course the epicenter, which is in the Chemko-Strážske, will have to be dealt technically. They will actually have to dig out all the barrels with these PCBs out and probably incinerate them heavily. But since it's been so many years back when this contamination occurred, the wind have taken the top contamination and smeared it all over the country. And the chicken in Michalovce, that far from Chemkostrárske, have in the eggs that they produce, you can find PCBs from all over there. Even there was not, any pollution per se, but the wind for many years have taken the soil contaminated with PCBs and smeared it all over the country. And that's where I think these phytostabilization, right, that's the term, could come into play, and even along the canal that goes to Zemplínska Šírava, the banks of the canal could be stabilized with the plants. So I think we have such areas in Slovakia, even this big, that could be very, very good candidates for phyto.
To look at it, yeah. And do you know if the PCB is also in the groundwater here?
No. The good thing about PCBs is that they are not soluble in groundwater or in water at all.
Sometimes they're taken.
They are taken with the organic material in the soil into the rivers, and they are sitting, for example, in the bottom of the Zemplínska Šírava. So people cannot, people who fish there cannot eat the fish. So the plants could. We had a picture there. I think it was a picture of Zemplínska Šírava, which was when it was dry. Can I go up here? Yeah, I can. There. So picture of Zemplínska Šírava when it was dry. And it's a huge problem because when it dries like this, all the soil around, is contaminated with PCB. So when the wind comes, it really, and there are people who actually go there for vacationing. It's a nice vacation place for many people from Eastern Slovakia. So the water is safe to swim, but the air can be, especially when the water is down, can be polluted with. And that's a perfect place to stabilize with plants, right?
Yeah, that's true. And you can use stabilization in it. And
but this is Eastern Slovakia. Maybe we could move back to Bratislava. You had a nice workshop today.
Yeah, we had. And but it's also what we discussed in the workshop as well. I told of course about the basics of phytoremediation. Also that it's not a cure for all. Yes. So that's a good thing. So you have to really look into it and see what is doable, what is a good way to do it. And we also talked about...
Where did you go?
We go to Sabi Maier.
Sabi
Maier. That's the most problematic area, I guess, here
in
walking distance. And, phytoremediation is not only a different approach than in Holland. What they do is just excavate the soil, but it's also like an in situ remediation thing.
Right.
So, and that means that you remediate the soil at place, and it has a lot of biological advantages. And when you go to Sabi Maier, you now see already that there's a lot of nature in place. And it would be really interesting to also do an ecological study to see what kind of animals live there, what kind of plants are there already living. Because I think most people that we went there today expected a sort of dead area. But it's not true. Nature does live on this polluted land. We see that at the Geuvel, which is really like sort of flourishing. You see that at Sabi Maier as well.
Maybe the plants there phytoremediate already.
Well, what was really funny is that we first looked into the kind of plants that would actually treat. It's more the volatile organic compounds that they have, and poplar and willow are really good at treating that.
And you found them there?
We found them a lot together with reed. So it would be really interesting to sort of start documenting what is already in place and maybe start monitoring that, and then see what you could add to that, maybe to make some sort of barriers for the groundwater to prevent the groundwater go into the polluted groundwater going into the garden lots that are there.
The groundwater is definitely contaminated.
Yeah.
And it's interesting because you were mentioning how many times people take from these contaminated sites the top soil, the top contaminated soil, and bring in the clean soil, and that is exactly what happened in Sabi Maier. I'm not sure if people here know which area we are talking about. We are talking about area close to Dimitrovka, and behind the railway there is záhradkárska oblasť. Yeah, there is lots of small gardens with like these sheds and garden houses where people plant their tomatoes and potatoes and
apple trees.
Right on top of a former landfill. Yeah, and what they did with the former landfill, they actually I'm not sure if they even took the top meter, but I'm sure they brought 2 meters of good soil from Žitný Ostrov to there to allow good gardening, which they did not really think about the fact that people installed wells, right, in their gardens, and a lot of those wells are contaminated. So their soil may be clean, but they are
kind of polluted it by watering
with the polluted water. So many of them actually asked us, they are our NGO, to analyze the water samples, and we did tell them that, look, this particular well is not good, and that is in this one we didn't find, because it's not all over, it's depending on what was in the landfill also. So we actually do that kind of service to people. Of course, sometimes they have to pay, sometimes we have the money, we co-pay these analysis. And but that is what happened in Jabi Mayer. So but people happily live there and do gardening. So yeah, they need help, and we have a discuter here. Somebody who wants to ask a question.
We have a question.
Go ahead, Ila.
You can use mine.
And what about here in Cvernovke, actually? Because this is very close to Jabi Mayer. Did you also do so?
Yes, we did take a sample here, and the water is not drinkable, right? We took the water sample from the well here, but you can use it for watering.
Okay, so it's not so contaminated.
It is not so contaminated.
Did you also test the soil?
No, the soil is too far, I think, from there. So no, we didn't take the soil.
You didn't take the soil.
But okay, this was a chemical school formerly, right? It was not a chemical plant.
So what did they do with the waste of the laboratories?
Yeah. Yeah, I think they sent it back to the chemical plant.
But it's one of the things that's really interesting, the history of the place, and it tells you so much about the possibility of pollution. I think that the sites we're talking about, it's really obvious with the big chemical industries, but a school like this would be really interesting to locate actually the fact where they had the laboratories and where they stored things and see if...
The thing with groundwater also is that it changes, right? So you need to also take several samples at a time and see, because if you take samples after it rains, the water may be clean, and then later it may not, depending how diluted it is. So also here in Cvernovke, I think we said, Ila, that we need to take more samples to be sure, to verify them. I'm not sure if she heard me.
We have the same thing actually at the Keuvel going on as well. I have no clue where I am in the presentation, so I'm just, no. Just pushing some buttons. But at the Keuvel...
You're in the Keuvel.
Oh, this is also something different, but what I really like, so since it goes by, this is the Keuvel at the start, and we just had planted. It was all just like mud and 2 old trees that were there. And this is like right now. So what gives me hope is also how quick plants grow and how fast something becomes something like nature.
And Anke, you said that you actually took some samples.
Yeah, we do.
Before and after.
Yeah.
Could you tell us how much the plants were able to take up from the soil?
Yeah, that's a good one. We had well, maybe you remember we had 2 major type of contamination. One is the PAH, or organic contamination. That went really well. It's also easy to do because you have to plant the right stuff, and then nature does it actually. If you take care of the plants, they work. And the test results showed that we diminished 30% on one location and 40% on the other.
That's a pretty good achievement, actually.
That's actually a really good achievement.
In a few years, because you said not all the plants at the beginning.
We're starting, but these took off really good. So that went really well. But then we also have the metal pollution, and that's difficult. It's really such a hard work with a lot of volunteers to plant, and then you have to harvest the plants every 2 times a year. So let me see.
That looks like a jungle.
This is nice, right? And it's also so nice for all the animals that are living there while we are cleaning up, and for us animals to live there as well in hot summers.
You did something with biodiversity then also.
Yeah, I really like it. These are the plants for the PAH. So the poplar is here in autumn, and you see the willows. They go really well. And these are plants that we planted also for the phyto extraction, and we have to seed them. And so we have to clean the soil and seed it, and then after a while they grow, and then you have to harvest it, and it's really labor intensive. And we did testing on the soil, and we knew that it takes a long time. For phyto extraction, it's really like decades.
So it takes quite a lot of, you said volunteers, but I would say dedicated people who would, with phytoremediation, who would actually take care of the land. It's not something that you plant and you go away and you come, once a year to look at the plants.
To look at the plants. No, there are, but it depends on what kind of technique you use. Like phyto extraction is really some labor intensive, especially because we have all these little plots between the boats, so you cannot just harvest in a big scale.
So the reason I'm asking, I think that maybe that goes well with what Punkt and CTZN wants to do is to look at these brownfields even now as living places, to really take out the, let's say, harmful part of the contamination, something that can pose a risk to people, and make the place inhabitable in some way, so that you can put the greens and plants and animals even in there, and mostly people who will be living in the middle of that, taking care of it, maybe have it as a little bit of a cheaper place to live, but also they actually earn it by volunteering and making sure that the place survives. Yeah,
that's exactly what I like, because it's one of the things I like about the Keuvel. It's that it's really taming with life, not only from nature but also from people, and we are all aware that it is polluted, and we treat it in a way that it helps and it feels good. And in this way, it's also not hazardous for us. So it's really.
If you don't mind, I will bridge to show you guys how many contaminated sites we have in Bratislava. I wonder if I can find it in this presentation.
I think you go the other way.
The other way. Oh, okay. And maybe you will be able to name them all. This is actually one of our IT experts in our NGO has made that picture. Here it is. So this is not all of them, but the major ones and you can see the blue arrows. So you can see Jabi Meyer up there in the north. This is where Anke went today with the students to take a look. And there you see a big 2 dark purple colors, meaning really a significant source of contamination. And one is Istrochem, former chemical plant, and the other blue, the purple dot there is the landfill from Istrochem. And then there is the airport, then there is Vrakuňa. This is actually a huge landfill, partly filled with chemical waste from Istrochem, but also from all other chemical plants that used to be operating in Bratislava. And then you see some others, landfills, Matador, there is others. But what is a common and not very lucky thing for us is that you see the blue arrows, and that is the direction of groundwater from these contaminated sites. And you see that all the contaminated groundwater, which picks up the pollutants from these sites, is flowing in the direction of Žitný Ostrov, which was shown on the video when I started, or as my intro. So, and that is what is scary for us, and that is why we really are urging ministry to do, first of all, a very good hydrogeological research to see how deep and how big the contamination is. Some of them have already started, like I said, some not, and we are really pushing more and more to have them started more, and maybe if they could remediate it as brownfield and later, sell it or have it used by people in Bratislava and revitalize it at the same time, that could speed up the process. Because today they are just thinking, oh, how horrendously expensive it is to remediate. But they are not thinking, they shouldn't think, okay, this will never happen if we don't find the hundreds of millions of euros, right? But we could go step by step and have not cleaned up fully, but really maybe do something partially and make sure that we prevent the groundwater contamination, but still have it remediated enough for people to live there.
I want to show you this because I think it's really, I believe in a combination of all techniques and just broaden the view. And if you can do things, since it's such a big area, it would be lovely if you could do it combined with a sort of landscape architecture. And this is one of the things that I found. It's the Ford factory in Ghent in Belgium. They have a PAH contamination with a large plume in the soil. That you see on the left side, you see the green dots is a hybrid poplar planting that they did for phytoremediation, and they wanted to see what for effect it had on the contamination plume. And you see the effect after 55 months of planting, so that's like, I don't know how many years, like 4 years, 4.5 years or something. You could see that the plume has now diminished a lot. It's now just barely touching the remediation area. And
so soon the poplar will have nothing to remediate.
No, they have to plant new poplar.
To plant new poplar.
But what you also see is before that, it only became bigger. So it became bigger and bigger and bigger, and then they started planting the poplar trees. And at first it came to a halt, and then it started to diminish. And it can also do so with contaminated groundwater. You have something called Phyto Hydraulics, because trees are basically a sort of pumps.
And poplar takes a lot of water.
Yeah, and I learned that they also do that with PCBs, but that are PCBs that are somehow in the groundwater or something, that they use it in Louisiana. So I can send you the project and just...
Maybe different kinds of PCBs. Yeah, there's different...
Yeah, there are different kinds. So that's... And I'm not a chemical engineer, but I know that it can do something with stabilization, but sometimes also with things like this. And how they do it, this is how they plant the poplar trees. This was a really deep groundwater, and there are techniques like they have this to plant trees in these boreholes so that they go deeper. So you can treat deeper groundwater with phytoremediation and making this way a sort of buffer so that the plume doesn't go further.
But this is, I'm sorry to add my chemical engineering background now here, but if I saw that this was a plume from BTEX, which means basically oil and stuff, so the trees that take it up, the poplar trees, and these are hybrids, so they're cut down every 5 years, and they can be easily burned as normal fuel, like a biomass. So
I think so,
they don't become a hazardous waste.
No.
Because the trees that pick up heavy metals, they do become hazardous
Yeah.
waste. So you have to do something special with that.
Yeah.
Maybe you can tell us what you do, because that's a separate story. These are for BTEX, for regular oil contamination, that is very easy. So the trees do a very good job.
They do a very good job, and you really get rid of it in a way. So maybe, and PCBs is one of the most difficult things to treat.
We have in Zemplean.
Yeah, exactly. But things other type of contamination, there are already a lot of sites, especially in America. They started to document them quite well, that have good effects.
Do you know if they revitalized the whole area around that plant?
No, I don't know.
Okay.
No, but it would be interesting. Yeah, and what we do with the harvest, this is really like, this is what we do with the harvest. I told you we're do-it-yourself the keuvel, and this is an area that is not, the rain doesn't come in, so we store it here, and we, right now is simply degrading, it's composting, but without waste, without the water having it, without seeping into the soil through the water that seeps through it. We were looking for different type of techniques to help us with the harvest, because actually a lot of the phytoremediation was still in a sort of when we started in a sort of theoretically way. It was done in laboratories, but not so much on a real site, especially not on such a brown field that we had. So once we got the plant started and we had the first harvest, we were just really looking like, okay, yeah, now we have to harvest, but who is going to tell us what to do with that? And the theory didn't
tell you what to do. Yeah, the theory was plant that plants.
So
they will extract some contamination, and nobody told you what to do with the plants.
So we had these students coming up from Wageningen University. It was really good university on this, and they looked for us. And one of the things that you could really do well with it is pyrolysis, so controlled burning.
Pyrolyza?
Pyrolyza. That sounds the same.
V podstate vysokoteplotná incinerácia, spaľovanie.
So that's a controlled burning. So in that way you could also still produce something from the biomass. You could produce biogas from it that's not contaminated, and you get the ashes that is contaminated.
So you've basically very much reduced the volume of contaminated stuff, and you can produce the biogas at the same time.
And what I would find very interesting is actually to combine it with phytomining, which is something that is also still theoretically and in a sort of, how do you say, tryout phase. But phytomining means that you win the stuff that's in the plants, you win it back to create metal. And
that's a good point. I'm not sure if we have time, but we have many of the areas in Slovakia that are called odkaliska, close to former mines, which are with leftovers from the mining material, which still have lots of heavy metals in them. But today it's either economically not feasible to extract the heavy metals or technically not so possible. So maybe the plants could take it and then we can harvest it from the plants. That's what
it would be very interesting, because now it's still not affordable, but when metal becomes more expensive, specifically specific metals, it becomes more and more interesting.
For sure.
Yeah.
But we are missing some guests here. Nobody wants to ask us any question.
We're so scared.
We're going into the last 15 minutes of the debate.
So who wants to have a chance?
So it's now or never. No questions if you don't sit in a chair.
Oh, come.
But it's going to be just a quick question.
Maybe introduce yourself first.
Thank you very much. So my background is in sociology, so none of this technical stuff, but I'm truly amazed by this talk. It's like really inspiring for me. And my question is pretty basic. So looking at those poplar trees, Bratislava has a lot of the poplar trees that just grow somewhere. Either they were planted or they just started growing. And my question would be like, how dense of a network of those trees you actually need to do something effectively? I suppose not a single one every now and then, but maybe you can tell us something about this.
That's a good, really practical question as well. Yeah. Really nice. Well, I think I have to look into that. I'm not sure how much. I read something about 7 meters apart, and then you have this forest. I believe that's the distance of the poplars of the site that I showed you. So in a sort of commonly planted forest, you will have about that amount, I guess. But it is interesting that nature is already planting a lot of stuff that is that's there. That this, if I can go, is that enough an answer for your question? So it's about 7 meters between the poplars, and yes, not one single poplar tree will probably not treat it, but then it comes all down to what is the kind of pollution that you have. Is the poplar tree really helping? Which is doing a lot, because poplars are very good in either degradation or volatilization. So it takes on quite some part of the pollution. Also, they have very deep roots, so they're really really helpful trees in this technique. But nature does a lot of help, because at the Keuvel, the first setup of the phytoremediation wasn't done by me. It was done by some sort of architect group, and they planned really like on a sort of white sheet of paper what kind of plants would be nice. And they knew some of something about phytoremediation, but they put plants in places that they didn't like. So shadow loving plants in sunset and the other way around. So and to have phytoremediation, you have to have healthy plants some way. As we told, if you don't have a good plant growing, the remediation doesn't take place. So, and I believe also in the power of nature, and in that it's in a certain way wise. So we started looking around, like this is the boat. This is my workplace actually. I work here every day. I'm really happy. And I looked around what kind of plants do grow here, and just to check if we could find any evidence of phytoremediation by those plants. And one of the plants that was growing here is the brassica. And as I mentioned in the movie, we find out that that's actually a very suitable plant for our area to grow. So it came up spontaneously, and now we seed it as well, and it seeds itself also, and it's really nice. So probably you're not only going to find the poplar trees, but also other plants that already are helping.
Because there on that scheme that you presented, it was almost like those poplar trees, they like constituted some kind of a fence that kind of fence off the pollution. So yeah, I figured. So I mean, the question is not only about the number of the trees, but whether you really have to have some sort of a density so that you kind of can't build this natural barrier.
Yeah, in this case, yes, they really build a sort of poplar barrier for the pollution. Yes. And that's also the, let me see, we're just skipping through to and fro. I like this image as well. Oh yeah, but I can show it with this as well, because I like this, because we're talking about phytoremediation of as a mean to clean up sites after they have been used, right? But there are a lot of areas, like this is a gas station, and a gas station, as we have nowadays, gives pollution every day. And you could also look for things in the planting, in the landscaping of a site like this, that helps already remediate some of that pollution. And this is an example of it from a book that I really love, Phyto. So it has this, they combine the phyto techniques with planting stuff. So they really build something that they call a degradation bosque. So they have this forest that's specifically placed for that, and that's really nice. So what you saw, it was really planted in that way because of the function it has for phyto.
In Sweden, they actually do plant dense poplar trees on top of not so hazardous landfills, and it's called actually short rotation plantation. So every 5 years they cut down the poplar trees, it's hybrids, and they grow again and again and again, and they just use it in boilers to create heat for a city. So thanks very much for question.
Okay, thank you.
Any more curious people or no?
I wanted to ask if we use this technique in Slovakia already or not. Yeah.
Mike.
I think it's more of a university kind of thing. So people test it in laboratories and they know about the techniques, but it's not so often used. But we do, yeah. But there is no reason why not to. It's just that, it's maybe this is a good start.
Yeah.
You know,
and I think
it's
not so surprising, because it was the same in the Netherlands as well. So it's really, in the universities, it's already quite a big thing, but a lot of people are looking into it. but also in the Netherlands there weren't that many examples. But this year, the interest in the Netherlands, the interest in the technique has grown, and now they want to create a platform of it, a platform of knowledge, so make it easier accessible, and also to spread the word that it's one of the techniques that you can at least consider.
And
So-
have the endpoint also, right?
Yeah.
You know,
Yeah.
what to do, because the plants, they really, really grow. I have a garden. I'm always amazed how much biomass it generates every year. It's beautiful during the summer, but it's so much work in the autumn, right? And then you need to do something with the biomass. And it's contaminated, so you need to sort out, the ones that are just contaminated with some oil can be, like I said, burned normally. The ones contaminated with metals, they need to be specially treated. So not only you need to think about where to plant the plants, but also what to do with them later. So I think that is making it a little more complex, but not impossible. So I think it's a great example.
Yeah, I think also because like now we have a sort of problem with our harvest, but as soon as we would have like 3 sites like this in the Netherlands, it would we know already someone who can build a mobile pyrolysis installator, so that's really good. Mobile unit to do it, and then but only is too small. But if there are more projects like us in the Netherlands, it would already solve it, and it would be easier. So yeah, so it's at the beginning.
Thank you.
Is there anybody who would like to ask a question before I step as the last person into the fishbowl? 3, 2, 1. Okay, I'm going in. When I was just listening to answer to the last question, and I was imagining at least last summer I visited you in the Keuvel, and I'm gonna take off my mask now. Yes, I visited you in the Keuvel, and seeing a project like the Keuvel really shows the belief that we had on one of the slides in the beginning of the evening, is that a real change can and usually comes from communities, from individuals that have good ideas, that are connected to what happens in the world, that are connected to their place where they live, and who want to basically make a change. Usually it's also so that they feel better, right? That their lives get more interesting and more connected, and and they do something for their direct environment. And this is really like this is like the bottom-up movement. That when I talked to you, I asked, what kind of support do you have from the municipality or from the government or from networks by doing what you do? Like how are you? And we talked about it. I'm going to give the answer. I'm not going to ask you a question now because we're wrapping up. But your answer was, and I also have it in our podcast that we have on Citizen. And your answer was like, well, we are actually doing the pioneering work in practice, and everything that everybody knows in these universities is what is written in the books and what they think it might work, etc. And what we are doing is we're bringing in the practice, and for this practice you need people, purpose, a place, and so this brings in how it connects to brownfields. And what you also said for me was very interesting. That what about temporary use of brownfields? What about bringing in people who want to make a space for themselves and spend some time in a place that gives them opportunity to grow and to connect, and they have this added value. So I think what is very interesting is now that the cultural sector has gotten into brownfields, and what about the green sector? Like bringing in basic plants and animals to this spectrum. And there's a reason why we're here in Novej Cvernovke, because we see this is what's happening in Novej Cvernovke. And eventually these things bring also the real change on a higher level. And when you were talking about mobile incinerators, I thought, about us 3 years ago with Dobrý trh looking for composters. Like, we are producing so many biomass and compostable food waste, and we're collecting it, but nobody can burn it. You know, nobody could make it, take it, and work on it. And after only 3 or 4 years working bottom up, we managed not only to motivate people to get these big composters, invest in it, but also the city of Bratislava now is making a huge, they're going to invest basically in a big composter for food waste, which is huge, and which is the, like what we like to talk in Punkt about it, that this is the kind of systematic change that happens, and it starts, you know, with a few people planting plants and having this toxic waste and not knowing what to do with it, or in our case it was, you know, the compost. So with this note, maybe I would like to finish, unless you have something to add.
No, perfect finish.
Yes. And I really want to thank you. This is a wonderful debate.
Thank you for having us.
Yeah, and
Really delighted, really thankful for being here and having to talk with you. It's really nice as well.
Here, it was really nice meeting you, Anke.
Yeah.